And today we do something called advanced substitution. And I think you're catching on by now when Saxon says a topic is advanced, it just means problems that are messier than what you've been doing so far. So we're going to do some problems today that have four different variables in them instead of just two. We're used to systems of two variables. If I have one variable I don't know, one equation is enough to be able to solve it. If there are two variables I don't know, I need two equations. If there are three variables I don't know, I'm going to need three equations. And like on this, with four variables that I don't know, I need four equations. And some of these are going to have one variable times another variable in them, which just makes them a little bit trickier to do. We've got the RWTW and the RBTB. So you see what I mean by two variables that are multiplied together. So then we start looking at the others. And it's like, oh, you know what? I've got this one right here that says RB is 3RW. So I think it's going to be pretty easy. I can substitute that right in here for this RB. That means I'm going to have 3RW and then times the TB. And you know what? I've also got TB equals, so I'm going to put that right in here into this one also. So I'm going to have the 3RW for the RB, and then I'm going to have 2 minus TW for the TB. And anytime we have a plus or minus in something that we're multiplying by something else, we've got to remember to put the parentheses around it. And that equals 6. Now, what's your first reaction whenever you see something times a parentheses? What do you think of trying to do in that work, Charlotte? Distribute. Let's see what happens if we distribute that. So if I multiply the 3RW times 2, I have 6RW. And if I multiply the 3RW times the minus TW, I have minus 3RWTW. And it still equals 6. So far I've used the last three of those four equations, haven't I? Haven't happened to do anything with the first one yet. So please notice this first one says RWTW equals 6. Anytime I know RW gets multiplied by TW, that's the same as the number 6. Instead of a single letter substitution, I'm going to do a double letter substitution today. Do you see how I've got that RW times TW right there? Right now, I don't know what RW is. I don't know what TW is separately, but I know if you multiply them together, it's 6. So I'm going to change that one to a 6, which means I've got this minus 3 times 6 right there. Now it should be pretty easy, and I bet some of you are already jumping ahead and finishing up the problem. I have minus 18 in there. So if I add 18 to both sides, 6RW is 24. And Alexander, what does that mean RW needs to be? So I have four variables that I need to find. So far I've found one, but I've made a good start on solving this system. Getting everything copied down? So RW equals 4 is one of my answers. And then I start looking at, well, what do I think I want to find next? And there's some choice on order here of what I want to do next. I could say, since RW I now know is 4, I could say that that means this is 4TW is 6. What will 6/4 reduce to, everybody? 3/2. I could also say, since I know that RW is 4, I could take this one right here, and I could say that RB is 3 times that 4. So I could say that RB has to be 12. That means I have RW, TW, and RB. I just still need TB. Well, TB, I could do this either of two ways. I could either do TB as 2 minus 3 halves, or I know that RBTB is 6, and I could put the 12 in there. How many want me to put 12 into RBTB equals 6? See a few hands up there. You guys go ahead and do it that way. How many want me to put TW 3 halves into this one? And maybe slightly more up. Most of you didn't vote. So if we did it this way, TB is 2 minus 3 halves. 4 halves minus 3 halves is 1 half. And did you get the same thing if you put 12 in right here? So now we've found and circled all 4 of those variables. Does that make sense to everybody? Do you agree that this is advanced or messy compared to other substitution problems? We're going to do one more. One thing I want to point out with these, most of the time, once you do a substitution like of RB, which we plugged in right here, you usually want your other substitution to be the one with the same subscript. If I do R sub B, I want to also plug in for T sub B, so that I will end up with these matching subscripts here that I can do the double substitution on. So one more here. So again, 4 equations, get those 4 equations written down. And then we're going to start substituting things in from one equation into the other one. So I'm going to look for one where I have one variable by itself equals. And this looks to me like my easiest one to start with. Would you guys agree? Because I already have just one variable equals. So I'm going to find that RP over here, and I'm going to change that to 3RC that then needs to be multiplied by TP. Then I'm going to look for a second substitution that I can do. And this is what I was just talking about. I have TP plus TC equals 12. That means TP equals 12 minus TC, and it means TC is 12 minus TP. But one way is going to be easier than the other. Because I just did R sub P, it's going to be easier if I do the one where I've got T with a subscript of P also by itself. So I'm going to choose this one, and I'm going to put that in for the TP right here. And then I have the 3RC that I already wrote down. My TP is now 12 minus TC, and that is still equal to 108. Give me a thumbs up, thumbs down. Are you with me, or have I lost you? Do I need to slow down, back up, go over that again? Yes. Say what? Yes, thank you. I told you guys I always need you guys checking my work on that. My eye went to the wrong equation when I got that far. I was plugging in for this RP, this TP, so that needs to be 288. And I really appreciate you guys saying it right then before we went on. And then we had to make everybody go back and erase stuff to fix it. Now, thumbs up, thumbs down. Are you with me, or have I lost anybody? Do I need to go back over anything? Okay, now what do we do next? We have parentheses. We have something times parentheses. What are we going to do now? Everybody. We're going to distribute. So that means we're going to have the 3RC times the 12. So 36RC minus 3RCTC equals 288. Okay, I've still got two different variables in this. Who can tell me what I'm going to do? So far, I've used three of my four equations. There's one I haven't used yet. What am I going to do there, Bryce? So I'm going to do the double letter substitution that the RCTC altogether is 108. And I had minus 3 times that. And I still have my 36 RC out in front. And so let's see, 324. And I was subtracting that, so now I think I want to add that on both sides. So 36 RC is 612. Does that look right to you guys? And somebody help me out. If I divide by 36, what does your calculator say we get? Is that going to be an integer or a reduced fraction? What do we come up with on that, Jonas? Anybody else 17? Just so we're double checking each other. See some other thumbs up. So RC is 17. We found one of them. Now we need to go back up to our system up here. So RC we now know is 17. So I see two places I can plug that in. That will let me get RP and it will let me get TC. So we've got RP is 3 times 17. What's that equal, everybody? How much? So 51. Why am I not seeing that on mine? RP. Oh, there it is. Just didn't look at the right place. So that's RP. And that also means we can say that 17 TC is 108. So TC is 108 divided by 17. Does that one simplify for us to anything nice? Nope. Okay, so that's as reduced as it gets. That one was RP. And that just leaves me needing to get TP, right? And so to get TP, you can either use either one of these equations. I think I'll go with the TP is 12 minus TC, and 12 minus 108 over 17. What fraction does your calculator give you for that? Brea, what does your calculator say? If we, it would have been 288 over 51, and our calculator nicely reduced it to 96 over 17. And we found all four of those. So anybody have questions on this? All right, let me give you guys your problem sets then.